Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at instance variables or data members in C++. I'm actually re-recording this video because in the first version I accidentally typed some C++11 syntax, which is not fully supported by all compilers at the moment in 2014. Although if you are interested in C++11, then I have an advanced course on C++ that covers it at caveofprogramming.com. So let's create a new project here. I'll go to File, New C++ Project. I'll select this Hello World C++ project. I've got actually two computers and one of them has this cross GCC on it, but I don't really know why. I don't remember installing it, but I'm going to use the default compiler here for my platform. Let's call it instance, maybe data members. I've already got a project called that actually, so I'll call this data members 2. Okay, that was my first version, which didn't turn out so well. It's good to make sure that you can compile your project as soon as you've got a hello world thing there, because occasionally I find Eclipse somehow messes things up. So I'm just going to compile this and make sure it does run before I start adding code to it. So this is a little slow, but it looks good. So I'm going to show you a different way of creating a class in this tutorial. In the last tutorial we created a simple cat class, and I'll show you a bit of a quicker way of doing it in this tutorial. So if you right click your project, you can go to New, Class. Now at the top here we've got this namespace which we haven't covered yet. We'll get onto that later, so I'm going to untick that because I don't want to use it. And we've also got here it says constructor and destructor, and we haven't covered those yet either, so I'm going to untick those as well. And in this class name here I'm going to give it a name. I'll call it cat, and you can see that this is going to generate cat.h and cat.cpp for me. So I'll click finish. And we've got here's the header file .h, and then we've got an empty class cat. We've got this usual if not def defines stuff, which just prevents your header files getting included multiple times in your .cpp files. We've also got this cat.cpp, which includes cat.h. So when the build runs, it's gonna basically, in effect, paste cat.h behind the scenes into this file because of this include statement, so they'll form like one kind of solid file. Now, the idea here is that the compiler will actually compile the CPP files as separate object files, separate .o files, and then it will link them all together to produce the final program. The fact that we've got the header files means that we can define stuff. We can define how our code will be used, how the code in the CPP files will be used, and we can include those header files wherever we need to use them, so that the compiler can actually compile our CPP file that includes this without having to look at this. That the CPP files are all compiled to object files, which are only linked together at the end, at the final stage, to create the program. Okay, so one thing we need to do in our main kind of file here containing the main function is we need to include our header file. So I'm going to, underneath the standard includes, I've only got one at the moment, but before the using namespace standards, any kind of using namespace statements, I'm going to include cat.h with double quotes here. Double quotes because it's a local header file, not a standard one. Now I can already go ahead and create an object from that class. So the class is like a blueprint. It's kind of like a plan for creating objects, and we can create particular cats using that blueprint. I'll actually call it Jim here, just because some people are a bit confused by using variables that have the same name as the class but with a lowercase letter. But I personally like to do that because I'm used to this convention of having uppercase letters for classes, lowercase letters for variables. But anyway, this will work. It won't actually do anything. It won't output anything, but it does work. So let's give cat a method. So first I go to cat.h, and inside these brackets of the class, I need to type public and colon to define a public section, and we'll see what that does very shortly. And in there I'm going to create the prototype of a function. So let's say void speak and then semicolon. So no implementation there, just the prototype, just the bit that specifies the name of the function, any arguments that it might take, and the return type. Then we go to cat.cpp and we provide the implementation. So we say void speak. This is the same thing again, but now we have curly brackets containing code after it. And we need to say that this is a member of the cat class. So I'm going to type cat : in front of this speak. And the autocomplete is trying to help me there as well. And let's put cout in here and meow to make a sort of cat noise. And to use cout, we need to include iostream.h. So I don't think I'm not going to need to use cout in my header, only in this CPP file. So in this CPP file, I can include iostream. So I'm going to go to the top before the include cat.h. Actually, it doesn't really matter too much where you put this include. I'll stick it here as long as it's at the top of the file before you try to use things like cout. And I'll type hash include angle brackets because it's a standard header, iostream. And then underneath all of the headers, I'm going to type using namespace standard, which we'll look at later on, but we just need that to be able to use cout from iostream. Now I can save that with the save all button, and I can go to my main function again, and now I can already call gym.speak. So gym is a particular cat object created from the class blueprint, and we can call speak on it. Let's just run it, see that it works. So there's, whoops, I mistyped iostream there. So let's go to cat.cpp, iostream, not iostream. Okay, so now it works. Let's run this, and we will get meow. Okay. Now, the idea behind a class is that you can have not only functions in it. If we have functions that are part of a class, we actually call them methods. It's a slightly strange terminology. So this speak is a method. And the idea behind a class is that we can bundle together methods, in other words, subroutines, with data. So if you think about something like a cat, any kind of what we call an object in the everyday sense of the word object, then objects like cats, they have things that they can do, which we represent with functions, with methods. And they also have a kind of state, like they're happy or sad, they weigh a certain amount, they have a certain blood pressure, whatever you like, basically. And we use variables to define the states of our objects. So the class is like a template for objects. So we need to specify in here what kind of states this cat can have, what bits of data are associated with the cat that can have different values in different cats. So I'm going to go up here above the public section here. Actually, no, I'll show you this in a minute. What I'll do for the moment is in the public section, so underneath the public keyword, I can type variables here. So I could put, for example, bool, happy. So by saying this, what I'm saying is that every cat is going to have a Boolean variable. Every particular object, every separate cat will have its own copy of this Boolean variable. So every cat can either be happy equals true or happy equals false, either happy or sad. Now, since this is public, I can go to my main function and I can access happy. So before I call speak here, I'm going to say gym.happy equals true. We'll save that and we'll go back to our function and we'll change our function so that it does something different depending on whether happy is true or false. So we'll go to cat.cpp and in here I'm going to say if happy then we'll output this meow. So I need to surround this by curly brackets. Else, let's put here cout, and we'll make a sort of distressed, annoyed cat noise like this. And I'm just going to use the auto format there to format that, so that's nicely formatted. Now, if we run our program, it's going to say meow as before, but if I set happy to false, then it says hopefully. So we can see the idea here is that whatever variables we define in our class, in our header, those variables can be accessed in the methods of the class, and they can maintain a state for the cat. So here in the main function, if I created another cat, let's call him Bob. Again, I could set bob.happy equals true and call bob.speak. Now we've got two cats. One I refer to with the variable Jim, one I refer to with the variable Bob. And Jim is unhappy and Bob is happy, so it's saying meow. Now what we usually try to do is we usually try to prevent this happening. We don't want people to set our the values of our class variables, our data members, from outside of the class. We want to encapsulate that kind of functionality. We want to encapsulate the variables within the class so that only the objects themselves can directly access those variables. And that means that if we were to change the particular variables that an object like this cat has, we could have more of these. We could have ints, doubles, whatever we like. If we were to change them, then we only have to change the code of this class, and we're not going to get stuff like this happening outside of the class, which would necessitate us changing other code as well. If we change the variables, we want to encapsulate those variables so they're only used within the class, and that means that as long as the method names and the prototypes remain the same, we can change the variables of the class, and we only have to recode the class itself. We don't have to worry that someone might have done this and worry about wrecking their code by changing what instance data we have, what variables we have in our class. So to arrange that, what I can do is I can go to cat.h and I can create a new section up here called private, and I can move this variable, any variables we've defined, into the private section like this. And that means when we compile it, we'll get an error. So if I build a project now, we get an error because it's telling us that we can't do this. We can't access these variables outside of the class. So let's delete this here. Let's get rid of those because that's not going to work. So where can we set happy? Well, one answer is we could use a constructor, which is a special method that runs when objects are created from your class. It runs separately for each object. We haven't looked at constructors yet, so we won't do that here. In C++11, we can actually set default values here. So this would be the initial value of this variable for all objects that are created from this class. But we're sticking to C++98 syntax in this tutorial because C++ is not fully supported by all compilers, and often with compilers that do support C++11, and that here in 2014, you still have to specifically enable C++11 support. So we won't do that because we can't do it in C++98. What we can do is give this a method, give the cat another method that can set the value of happy. So let's give it a method like, we'll say void. Let's pass in a value for happy here. So let's say void, in fact, no, I'll do something even simpler here. I'm going to say void make happy, and we'll just put the prototype for that here. And we'll also have void make sad, like that. Let's implement those functions. So I'll go to cat.cpp and I'll say here void cat : make happy, and we'll say in there we can access any variables that we've defined up here. So we can say happy equals true. And let's also add void cat make sad. And here we're going to say happy equals false. So now we can run these methods for our objects to make the cat happy or sad. So we'll go to our main method here, and after we create the object Jim and before we call speak, we'll say Jim.make happy. And for Bob, we'll say Bob.make sad, like that. So now if we run this, it looks similar to what we had before. Jim is happy, so says meow, and Bob is unhappy, so says s. Now these instance variables are not automatically initialized to anything, so this will have a value. So if we didn't call make happy or make sad and we called speak, we'd get basically a random value for this. Not a truly random value, but we just get whatever happens to be in the memory that this happens to use. So you have to initialize variables before you use them. And a common thing to do, since you don't want to force the user to have to call some method before they can use other methods, that's very confusing. Normally you use constructors in C++98 to initialize these variables, and we'll get onto that later. So it's worth having a go at this, of course, and create your own cat or whatever you like, create any kind of class that you like, try creating objects from it, give it a method, and then give it some variables which you then use in your methods in some kind of a way. And you'll also need, if you stick to the syntax that we've seen so far, you'll also need to create methods that can set the values of those variables to whatever you like. So you can use ints, use booleans, use doubles or whatever, although remember that it's not good to compare doubles with equals equals because their values are not stored precisely. So if you do use doubles, you want to really use less than or greater than if you compare them in an if. But anyway, well worth trying. So that's it for this tutorial. Until next time, happy coding.